is on key features of a function. First thing we're going to look at are the independent and dependent variables. The independent variable is your x. The independent variable is the variable that stands alone. So the variable that stands alone and isn't changed by the other variables. Isn't changed by the other variables that you are trying to measure. So again, the independent variable is the variable that stands alone and is not changed by the other variables you are trying to measure. So in essence, if we're thinking of cause and effect, this, the independent variable, is the cause. Whereas the dependent variable, since the independent variable is the x, the dependent variable is your y. This is the variable being tested / measured, and it depends on other things. So this is the variable that will change. And in the case of cause and effect, this would be the effect. Something happens because of the independent variable. So the dependent happens because of the independent variable. Next, we're going to talk about, so these were the independent variable, the dependent variable. Now we're going to talk about the x-intercepts. The x-intercepts are the x values when y is equal to 0. And it is the coordinate or coordinates because you could have just one or you could have multiple when the function or the graph crosses the x-axis, which is why it's called the x-intercepts, because it is intercepting the x-axis. You write this as a coordinate of parentheses. Your x value is going to be a number, comma, your y value is always going to be 0, and you close your parentheses. This is how you write an x-intercept. Below that, we're going to talk about the y-intercept or intercepts. Most of the time, you're only going to have one y-intercept because if it is a function, it should only cross one time. The y-intercepts are the y values when x is equal to 0. And this is when these are the coordinate or coordinates when the function crosses the y-axis. Now again, in an actual function, you should only have one y-intercept. The coordinate, and a y-intercept is always written as a coordinate, is written as parentheses 0, comma, whatever your number is, close parentheses, because it is when the x value is equal to 0. So an x-intercept is when it crosses the x-axis, which is the y is 0. The y-intercept is when the graph crosses the y-axis, and that's when x is equal to 0. The next piece of our key features is going to be our minimum of a function. We're going to talk about the minimum and the maximum of a function. The minimum of a function is the lowest coordinate on a graph. It is the value is the y of the coordinate. So it's going to be the lowest point on the graph, so that lowest coordinate. The value itself will be the y of the coordinate. The x is the location that it happens, and the y is the value that you end up with. So the maximum would be the opposite of that. It's not the lowest, it would be the highest coordinate. So the highest coordinate or highest point on a graph. And again, the value is still the y of the coordinate. So again, the time it happens or when it happens would be the x value of the coordinate, but the actual minimum of the function, the value, is the y of that value or of that coordinate. Next, we're going to look at two graphs, and we're going to see what the x-intercepts and the y-intercept are, and we're also going to look at the minimums and maximums on this side. So this first graph, we're going to find specifically the x-intercepts and the y-intercept, and we have a table and a graph. So we can look to see on this table, we have x values and we have y values. So we actually want to look for when the x values are 0 and when the y values are 0. So if I look at the x values, I have an x value of 0 here and the y value of 4, so that is a coordinate. Then we have a y value of 0 here, so the coordinate is at -5, 0. And if we look at the y values again, we have another y value of 0 at 6, 0. Now if we look at our graph itself, we can see the y value of 0 here is where it's crossing the x-axis, and another location where it crosses the x-axis. Then we have a location where it crosses the y-axis. So we have 3 locations. This coordinate is your x-intercept as well over here. So we're going to write those out. The x-intercept, there are 2 of them, that is at -5, 0, and that's that coordinate in pink here, -5, 0, and we also have it at 1, 2, 3, 4, 5, 6, 0, and that is the coordinate from the table, parentheses, 6, 0. And our y-intercept, we only have it crossing the y-axis one time, so we only have one y-intercept, and that is at 0, 1, 2, 3, 4, and we can see that that is 0, 4 in our table. So these are our x-intercepts and our y-intercept. So if we come over to this graph on the right, we're going to find the minimum and the maximum. So these are going to be coordinates. So we want to look to find the point on the graph that is the highest and the point on the graph that is the smallest or the lowest. So first, the lowest is going to be right here. That is the lowest point on the graph because there's nothing below it. The highest point on the graph is up here because there's nothing above that point. These are considered your minimum and maximum. So this highest point is your maximum or your max, and your lowest point is your min or minimum. So we're going to write over here the max coordinate. is at, this coordinate is at -2, 6. And the max value is y equals the 6 from that coordinate. So our minimum, so our min coordinate is at, their x value is -4, our y value is -3. So -4, -3. And therefore our min value, so our minimum value is at y equals -3. So on a table, our maximum y value would have a 6 and our minimum y value would be a -3. That tells us that all of the y values are between -3 and +6. There's nothing above +6 and there's nothing below -3. Next, we have function notation. Function notation is different. It is written for specifically functions. We will be using f of x for function. So this is a function of x. And f of x really is the same thing as saying y. F of x is your y value. We pronounce this as, write that out, as f of x equals y. So what this means as a coordinate, normally we see x comma y, but in this case our x is still x because that is the independent variable, but our y value is now f of x because it depends on the x itself and the function itself. So our y value would be replaced with f of x. And again, this is just saying the y value of the coordinate. Function notation is just so that you can make sure that you have this with regards to the correct function. This x is still our input because it's our independent variable. The f of x is still our output because it is still our dependent variable. So as an example, if it says f of 2 equals 3, this is telling us that the 2 is in replace of the x. So if you can see, the 2 here is in the same location as the x. That means that the 2 is our x. So x is equal to 2. See that the 3 is in the same spot as the y. That means that the 3 is the same as our y. So we can say that y is equal to 3. This is telling you a coordinate of the specific function of f. So I can graph multiple different functions or multiple different graphs, and I can make sure I know which one is the correct graph that I'm looking at. So in this case, our coordinate would be written as the x is 2, comma, the y is 3. And that is what function notation does. It lets you use the x value of whatever it is to find the y value of whatever it is on that graph. Next up, we have our domain. So we did function notation. We're going to do domain and range. Domain are all inputs, or in other words, your x's that go into a function. This does not mean that every single x is allowed. It is specifically for the function that you are graphing or the function that you were given. You read the domain from left to right because you want to go from smallest to largest. The left side of the graph are the negative numbers and the right side of the graph are the positive numbers, and that makes it go from smallest to largest. Now the range are going to be all of the outputs which in this case is the y's. Outputs are your y's because they depend on what you put into the function. This is all the outputs or y's that come out of that function. So come out of a function. And again, it's not just any y value, it's specifically based on the function, and what x's you put in are the inputs, and then what you get out of that are your y values, which is your range. And these, as we want to read them, we again want to go from smallest to largest, but they're the y's. The y's are on the bottom of the graph, are the negatives, and then the y's going to the top are the positives. So we read it from bottom to top. Because again, it's always going from smallest to largest. That is how we write our domain and range. So if we look over at this graph here, we can go ahead and write out our domain and range, and we'll do the next piece in just a second. Our domain, we want to find the values of our x's that it starts at and that it ends at. So if we're looking at our x's here, the very first coordinate on the left-hand side is at -4, 1. This is our first coordinate on the left. So that means that our x values start at -4. And we want to go to the right-hand side of the graph. So it goes from left to the right. So I'm going to leave a little space here because I know that these have to be our x's. So I'm going to put x's in the middle because I know that all of my x's are in between these two coordinates. My furthest thing on the right-hand side is at 6, -1. So the furthest one on the right-hand side is a +6. Now, I know that all of my x values are in between -4 and 6. So all of my numbers are bigger than -4. So my x's are going to be greater than or equal to -4. So we read this as -4 is less than or equal to x. I put the equal sign because it is a solid point. If it was an open circle, I would not have the equals to sign. On the other hand, on the 6, I know that all of my numbers are smaller than the 6, so I would say that x is less than, and since it is solid, is less than or equal to 6. Now, when we do the range, I know that the range is for the y value, so I'll go ahead and put the y values in the middle, and I want to read it from bottom to top. So I want to find the point that is the lowest on the graph. So not just these two dots here, I want to actually look at the actual graph and find the minimum location. So that was here. And then we also want to find the largest or the highest point on the graph, which again, we go all the way up to the top and find the thing that is the furthest to the top. So this coordinate for the lowest is at -1, -4. Well, I need the y value of that, which is at -4. So I'm going to put that first because it should always be the smallest first. Then I want to go to my maximum coordinate, which was at 3, 3. The y value of that is at 3. So I'm going to put that on the furthest for the y's. Now I know that all of my graph is in between those two locations as well. So there's nothing below that -4 and there's nothing above that 3. So when I write this, I want to say that all of my y values are above -4. That means that -4 is the smallest. So I can say that -4 is less than, and since this dot is also solid, it would be less than or equal to the y. Then for the 3, so above here, there's nothing above it, so all of my y values are below the 3. So I would say that the y is less than, and since, again, this graph is solid up here, I would put less than or equal to 3. And that is our range. So we have our domain and our range. We know that all of our coordinates are between the x values of -4 to 6, and all of our y coordinates are between -4 to 3. That means I could draw a box around this from -4 to 6. I could draw from the x values of -4 to 6 and my y values from -4 to 3, and every piece of that graph would fit inside of that box. So the next part, we're going to talk about the increasing and decreasing intervals. So this is called the interval of the domain. So we are specifically focusing on the domain. That means that we will be using the x values. And we already know that our x values are going from -4 until 6. There's nothing smaller than -4 and there's nothing bigger than 6. So we know that all of these intervals can only include the numbers from -4 until we get to 6. So we're going to look at the interval of the domain that is increasing. That is not talking about as the x values get bigger. It's talking about as the graph goes from left to right, when is the graph going up? So we're going to write that out. Increasing is as you read from left to right, because we're talking about the domain. So as you're reading the graph from left to right, increasing is the x values where the graph is going up. And that means that this is increasing y values. So this is why it's a function. So as the f's increase, or as the x's increase, what are the y values doing? So as the x's continue to go right, the y values are going to increase. That means go up. Decreasing is the same thing, but it's as the x values are going from left to right, the graph is going to go down because the y values will decrease. So again, as you read left to right, the interval of decreasing is the x values where the graph is going down. So again, that is as the x values increase, the y values are decreasing. So it is decreasing y values. So we can think of increasing and decreasing as a roller coaster. So if I come over to this graph, I want to have my increasing intervals in orange, and I'll have my decreasing interval in green. So I'm going to do two different colors so I can distinguish between them. Okay. So I'm going to start my roller coaster at the very first location because it's from left to right. So at the moment, it is not increasing or decreasing because it's just stationary. So this is not included when we say increasing, decreasing. I want to know as I move, as I draw this, is my marker going down or up? And in this case, it is going down. So I know that here is going down. Then, as I get to the bottom here, it's actually going to change directions like a roller coaster does. Now the graph is going up. So I'm going to keep going, I'm going to keep going, I'm going to keep going, and then it comes to another change. It comes to that spot here where it has reached its hump, and now it's going to go down on the graph. And then it comes to a stop. So I have two different things happening here. The first part of the graph is going down. It changes and goes up. Then it changes again and it goes down. So we actually have two decreasing and one increasing. So what I'm going to do is I'm going to highlight these with the correct highlights. So I had decreasing, we saw that decreasing went first, and that was supposed to be in green. So I know that it's starting here and it's going to decrease. That is my decreasing there. Then it changed to go to increase. So I'm going to highlight that in orange. Then it switched again, and it went back to decreasing. So I'm going to highlight that in green. So I have 1 orange and 2 green. So when I write this out, I know that I'm going to have 1 interval for increasing, but I'm going to have 2 intervals for decreasing. So I'm going to write this out as for the increasing, because that one's coming first here. These again are the x values. So this x value that it starts at, I'm going to just mark it. That is where that coordinate of -1, -4 is where it switched from green to orange. Then I can also mark from orange to green happened at 3, 3. So I'm just going to mark those. For increasing, which was the orange, the start of the orange, again, is the x values. So I'm going to put the x in the middle since I know it's the x values. It starts at the -1. The first part of the orange is at the x value of -1. So I'm going to put that on the left-hand side. Then the end of the orange happened at the x value of 3. So I know that all of my orange is in between the -1 and the +3. So I know that -1 is the smallest. So I'm going to say -1 is smaller than x, and x is going to be smaller than 3. Now, I am not putting the equals to sign because at this -1, where it went from green to orange, it is not going down or going up. It is basically standing still. So it is not included in the interval because it is not increasing or decreasing. So we cannot include it. This is just where it changed locations. So for the decreasing, I'm going to look at the green. Now I have 2 different green ones, so I'm going to have to write out 2 different answers. So my first answer, for the first decreasing, I know it's still the x value, so I'm going to put x in between. I have the first x value, so on the farthest left, the first part of the green is at -4, 1. The x value is -4, so that's going to be on the far left. Then the end of that green happened at -1, -4, so the x value again is -1. And that makes sense that these 2 numbers match because it went from green to orange at that location. So these 2 numbers do match. Now, this first green is all between -4 and -1. So I know that -4 is going to be the smallest. So that's going to be less than x. And x is going to be less than -1 because it's all before -1. Again, I cannot include these 2 numbers because it is neither increasing or decreasing at this first dot because it is just staying there. And when it changed from green to orange, from decrease to increase, it is not actually moving here, it is stationary. So that's the first green. That's the first decrease. Then I have my second decrease. So I'm going to show, this is called a union because I have 2 different greens. I'm going to do my second green over on the other side. I still know that these are x values. My first part of this second green is at 3, 3. So the x value starts at 3. And again, that's the same number in the orange because that's when it changed from orange to green. Then the ending of that second green is at 6, -1. So my x value is at 6. I know that the 3 is the smallest part of that green, so it's going to be less than x, and the 6 is the biggest, so all of the x's are less than 6. Now, if we look at our domain real quick, we see that our smallest number on our domain is -4. And if we look at all these intervals, -4 is your smallest number. And then your biggest number is 6, and we can see in all of these intervals that 6 is the largest number. So that's why it is the interval of the domain, because we're using from -4 until we get to 6. Now again, I'm going to make a note of what this symbol was in the middle. This symbol means union. And it means that we have 2 different sections. I'm also going to make a note that our interval does not use the less than or equal to symbol because it is not increasing or decreasing where it turns. Which is why we, in our domain and range, it does in fact include those numbers. Those are solid there because it says all of the x values between those and all of the y values between them. Our increasing and decreasing intervals happen on the domain. So as we read the graph left to right, when is our y values going up and when are our y values going down? So it's going down, then it turns. It does not include that value at -1 because it is turning there. It is neither increasing nor decreasing any longer. It is stationary. So these are the important information of the key features of a function.